With Singapore celebrating 100 years since aviation first started here, Singapore has become one of the leading countries in aviation. With Singapore's aviation sector increasing rapidly, the carbon footprint left by this industry is far greater than what is imagined. Therefore, new methods such as green initiatives have to be proposed to decrease the amount of carbon produced per passenger. One device in all airplanes responsible for this is the auxiliary power unit. Therefore, my team has come up with a combination of ideas which we believe will greatly reduce the carbon emissions of today's modern jumbo jets. Our idea comprises of the use of a ram air turbine and the use of multiple piezoelectric devices. These devices will generate electricity through kinetic energy. The energy will be stored in chargeable sodium-sulfur batteries which will replace the auxiliary power unit. By replacing the auxiliary power unit, carbon emissions will be greatly reduced. The first step in installing the designs into current airplanes will be to replace the control panel for the auxiliary power unit with the control panel for the sodium-sulfur batteries. This control panel includes vital information on the batteries and controls for the activation of the RAT and piezoelectric devices. This will allow us to replace the auxiliary power unit with the sodium-sulfur batteries. The sodium-sulfur batteries will now act as an auxiliary power unit, carrying out the responsibilities of the auxiliary power unit. The sodium-sulfur batteries will be used for vital aircraft systems before the engines are switched on, before taking off, and after the engines are shut down after landing. These aircraft systems include cockpit controls, cabin cooling systems, cabin lights and aircraft lights which will be powered by the sodium-sulfur batteries. With this installed, the pilots will now be able to control the sodium-sulfur batteries in the same way the auxiliary power unit is controlled in the cockpit. The auxiliary power unit is placed at the tail of the plane. It works as an engine to power vital aircraft systems when the aircraft is on the ground with the engines switched off. This engine is powered by diesel, and therefore accounts for the large carbon emissions from aviation. With few hundred planes using the auxiliary power unit for ground operations at every airport in the world 24/7, the amount of carbon emissions is enormous. These emissions have to be minimized, thus replacing it with sodium-sulfur batteries. The ram air turbine is a small turbine connected to an electrical generator or hydraulic pump in an aircraft and can be used as a power source. The RAT generates power from the airstream due to the speed of the aircraft. A device that is capable of generating 200 microwatts of power for every 1.5 grams of vibration amplitude it is exposed to. With the vibration of the RAT, electricity can be generated and stored to supply electricity when the plane has landed. The sodium-sulfur batteries will then store the power generated by the turbine. 4 small turbines will be installed on the aircraft. 2 on the belly, 1 on the nose and 1 on each wing. As the plane flies in the air, the turbine blades capture wind energy and start moving. They then spin a shaft that leads from the hub of the rotor to a generator. The generator turns that rotational energy into electricity. To ensure that the turbines always face the wind, the turbines will be equipped with a motor that allows it to change its direction. A device made of piezoelectric material will also be installed on the turbine. This device will have the capability of harnessing energy from the vibrations of the jet engines and converting it into electricity. Even though the electricity converted may be small, it can be able to power up the primary flight display or other small systems which are required during system testing. With the plentiful amount of airstream during flight and vibrations from the jet engines, the energy created could eliminate or reduce the use of the auxiliary power unit significantly, as planes use power from the engines during mid-flight. But with the energy created in mid-air, how can we store them for use on the ground? Currently, Xcel Energy Inc. is attempting to store wind energy for later use. A series of sodium-sulfur batteries is currently being tested on their ability to store the power generated by the wind energy. These batteries will have the capability to store the power generated by the turbines and store them until the plane engines are switched off. Sodium-sulfur technology has been chosen due to its high storage capacity. It also has the ability to go through a large number of charge-recharge cycles as would be incurred with an intermittent renewable energy source. The technology has also demonstrated its commercial performance and availability. Even though storing energy using sodium-sulfur batteries may be expensive at this time, the Director of Corporate Planning for Xcel Energy Inc. says that further testing of the batteries would help understand the value of the batteries more and reduce the cost of storing wind energy. One ingenious way would be to store the energy created with sodium-sulfur batteries. However, due to the highly corrosive nature of the sodium polysulfide, extra measures will be put into place to ensure that the batteries run smoothly without risking the safety of the aircraft or passengers. The size of the batteries will be decided by the airline operating the aircraft. With this set in place, planes flying short-haul flights can use the same battery for an average of 3 years, and those flying long-haul flights can use them for 3.5 years. With the rapid expansion of multinational businesses, the aviation industry will also need to expand to cope with the rising demands of air travel. Imagine an international airport with hundreds of planes running on batteries instead of their auxiliary power units. The amount of pollution produced will be greatly reduced. This will make the aviation industry much greener and environmentally friendlier. Well, not only does our idea minimize pollution, it also improves the safety of aviation. How is that so? As not all planes can start up their auxiliary power units in flight, the amount of alternative power available during emergencies are very little. With our batteries, the RAT would go back to its primary use, which is supplying electricity to the vital systems of the aircraft like the flight controls, hydraulics and flight critical instrumentation. With the addition of our sodium-sulfur batteries, they will be able to provide power to deploy the flaps and landing gear. Even though there are already ways on deploying the flaps and landing gears, using the batteries will allow the flaps to deploy faster and ensure that the landing gears are locked into place. Therefore, our project will not only make aviation much greener, but at the same time, bring the standard of aviation safety to a much higher level.